First of all, thank you all for coming indoors on such a beautiful day. I might have chosen something else if I'd known it was going to be this awesome weather. I'm going to talk about evolution. Few caveats before I start. The word evolution is here before Rebecca's awesome book came out, which came out sort of in the last year, I think. So if you read it, you might think, yeah, well, that's a different definition of evolution. That's true because I didn't have her awesome definitions. Well, who am I? I don't like pictures, so I didn't put a picture, but I know I'm being filmed, so. I guess I basically started off as a developer, played a lot of different roles. When things were not called DevOps, I did that. Did analyst roles, but they've always had a techie slant. And right now I'm mostly like a tech principal, which is basically like the lead tech person on most of our clients. I worked in sort of like retail, public sector, and financial sort of domains, and in some sort of variety of tech stacks. Most of it, 80% of it around the JVM, but lots of other stuff as well. I want to sort of put some context onto what sort of space we're talking about. Of course, I can't reveal any real details because of confidentiality needs, but so I'm going to sort of talk about enough things so that we can get an idea. So it was a UK public sector client. It administers a set of financial products available to UK residents. So maybe an analogy you can draw is like maybe an insurance company that makes available a set of insurance products to a large number of people. They were not in the insurance industry, but something financial. Depending on how you count, the word product is really difficult to define, but depending on how you count, there were 40 to 50 different products they offered. Because they were public sector, there's a lot of policy and regulatory needs that they need to follow. And policy regulatory needs in public sector, it may seem a little bit like financial, but it's a different, there's some intersection, but it's a bit different as well. And I have been personally sort of there for 3 years in sort of 2 different stretches, trying to help them re-platform their core systems. There are some key constraints. These were sort of immovable constraints because like changing them was just a big deal. So they were sort of like a single body that helped execute the policy intent from 4 different government bodies and then supplied software to 4 different operational bodies. Cross-organizational politics going on. They were tied to public sector budgets. And some of these will become, why I'm mentioning this will become apparent later on, but so the budgeting process was such that you need to decide on the budgets 1 year before the financial year starts. The financial year starts in April 2018, then in around April 2017, you say, okay, I am expecting this much amount of spend on the software for next year. That really is hard in terms of estimations. So those are the sort of constraints, and for this discussion and this context, we sort of assume we can't really change them because it's really hard to change them. In addition, they had some baggage as well. So I mean, these are also like constraints, but they were their own creation. Like the other things, they're sort of slave to other things happening in the UK public sector, but these are their own creation. And I mean, you can read them. They had a large legacy estate. People have a different definition of legacy, so I'm just saying like it was more than 15 years old technology. Heavy change management process. I think when we landed there, they had like 1 release every 2 months, which went through a long manual end-to-end testing cycle, shared snowflake environments on-prem, manually configured infrastructure. Okay, so what did we achieve? So we sort of, I like to call it, we built a technical oasis, technology oasis in that sort of desert from a technology perspective. We right now own and maintain 30 plus services with a mix of Java and Clojure. So we sort of own these 30 services. We build a lot of shared components for those 30 services. We gave them back to other parts of the organization who were slowly picking it up. We sort of reduced the time. So we have automated pipelines. So once you commit code, sort of be in production for 2 hours. Be in production within 2 hours. And if you want to sort of create a new service, you can do it in sort of 1 day. And so when I submitted this talk, I had a list of 20 things that I wanted to talk about. And then I looked at the time slot I had, and then I reduced it to 3 things. And now I'm worried that's not going to be enough. But anyway, so I picked up 3 things which I found special. Well, 2 things that I found special with this client, and a third thing that I think I'm seeing as a recurring pattern across a number of clients. So the first thing I'm going to talk about is this thing called long tail. Long tail is pretty much generally recognized by this graph. What is this graph? I guess if you, in whatever industry or sector you're working on, if you take the set of products that are offered in that industry or sector and arrange them in decreasing order from left to right, and the y-axis is the number of times it's consumed, and you get this shape, then it's referred to as the long tail. So the right-hand side, the yellow portion is the tail. The left-hand side in green portion is the head. The surface area of the yellow portion is significantly more, if not equal to the green portion. So just in terms of like drawing an analogy, a typical analogy drawn is the movie rental business. So if you take the movie titles that people would like to see or people to see, and again sort them in order from left to right, left being the highest number of watches, right being the lowest, then you get this sort of graph. If you heard of this organization called Blockbuster, it was based in America. It would rent out DVD titles. The Blockbuster, if you analyze their sort of business, they would operate in the green area. And it's capitalist organizations love operating in that green area because the amount of stuff they have to do, the proportion of the revenue versus the amount of stuff they do is the highest there. So basically for this, let's say Blockbuster was a DVD rental, have to, let's say, keep an inventory of, I don't know, 100,000 DVDs, but they get the most usage out of it, they get most revenue out of it because every view is extra money for them. When sort of Netflix came along, everybody said, oh, they were going to operate in the long tail. I don't think that's particularly true, but they can push the boundaries a little bit more because the inventory is not like shelf space or hard drives. The inventory is different. They need a data center or something like that. So they can push the boundaries a little bit more. So they operate a little bit in the green and a little bit in the yellow area. But what if the organization has to operate in this whole area? So that was what I sort of learned at this client. Because it was like a public sector client, and I think now I realize it's true for a lot of public sector clients, they have to satisfy all customer circumstances. So how did this impact our evolution model? I mean, it's obvious from the diagram that you have to cover all these different circumstances, but its effects are not obvious. How do I explain it? So let's go back to our insurance example. KYC is a common process in financial companies. So let's say you do KYC for UK citizen. Okay, big deal, not a big deal. Let's say you do KYC for an EU citizen. Okay, not a big deal. But let's say you do KYC for prisoners. Let's say you do KYC for refugees. When you have to deal with these many customer types, it becomes really, really difficult to provide the ROI model that we talked about as the sort of constraint the organization had to provide it, and just fundamentally deliver that much, right? Like it's exponential in terms of the number of circumstances that you deal with. There are really only sort of 2 options to go forward. There were only really 2 options we could think of to go forward. So either we could have built a sort of walking skeleton approach where the software does the bare minimum lowest common denominator that's required across those different cases, or we could have tried to build as many of those cases as possible. So we did 2 things. So one is we started with the walking skeleton approach. So again, if you go to the insurance company, what we did is we built the basic integrations that the insurance company needed with the outside world. So maybe there's insurance payout, so you need to integrate with the payment gateway. Maybe there's you need to receive an application of insurance from a customer. So you build all that stuff, but you only build core components about deciding how much insurance they are getting for a small set of circumstances, and then leave it on human intelligence to do it. But that's where this whole evolutionary aspect came in, because over time we automated more and more cases. So if you go back, if you think of that graph, we basically prioritized it based on that volume, and over time we sort of automated more and more scenarios, replacing human automation with bot automation. So every new scenario where we'd get the feedback loop of, well, this scenario is taking a lot of time, it's costing a lot of money, it's taking a lot of human effort, we would automate that scenario. And so then we, like after about 18 months, we were at a scenario where we had automated maybe 60% of the scenario. It was incrementally. By building a lowest common denominator that addresses your edge cases, it really pushes your ability to reuse building blocks. So you can reuse infrastructure building blocks, you can reuse some library components that are sort of, I don't know, logging components or authentication components, but you can't reuse the core business logic because the business logic is different for each of those different circumstances. Everything in this organization was about policy need. Yes, there are user needs, there are customer needs, there are operational needs, there are security needs, but policy needs reign supreme. Policy had very interesting attributes in this organization. Every year, a new policy spec was published by the government, and it was a function, it was dependent on previous year's policy. At any particular time, there are about 300 to 400 policy cohorts live. What I mean by policy cohorts is because every year there's a new policy spec published, and it's specific to a product, it's specific to a year. Because the policy cohorts' lives are really long, that brings in an interesting tension of evolution and longevity, right? We all say we build for evolution, but here, the policy requirement is that your outcome shouldn't change for the next, let's say 15 years. So that's interesting things. Policy cohorts are also guarded by transactional protection classes. So anybody applying, let's say for insurance in, I don't know, 2018, but immigrated into the UK in 2015, still needs to be given rules or policy based in the year 2015. So there's transaction protection clauses that means that they are not given any new, the new set of policies is not applicable to them. Now, this was a very sort of, I'd never come across this scenario because I'd maybe not worked in this kind of thing, this kind of business, but I was trying to think about what can I do, what can I look into code in terms of understanding how this impacted our code, right? So what metrics can I see? Or how can I visualize this? So I thought this was an awesome example of how code half-life worked. So basically, every shade of color is the code that was added in a particular year, and then it shows you how much of that code is living across multiple years. And I thought this was an awesome visualization of how your code had evolved, because either you had figured out some segregation. So these big drops in code is being deleted, right? So either you've moved that code out into a different repository, or you've removed feature bloat from your product, or you've deleted it because it was unnecessary. But there was something that's happened that after from, I don't know, 2000, wherever it starts from, to 2016, your actual total code is lesser. A good sort of code, half-life code, decay graph probably looks like this. This is actually Ruby on Rails code base. So as you can see, every year they've been adding new features. So it's added new layers of code on top of it. But they've also been reducing previous layers of code, deleting previous layers of code. And I think this makes sense to me because Rails, let's say, does a lot more than what it did like back in 2005. In general, any such finger chart, which is where the slopes are going downwards from left to right, I think is a good sort of code half-life graph. So I did this analysis for the code we were writing at our client. And again, I can't show you that actual graph, but I found another graph which sort of shows what I saw we were doing. But basically, I discovered that every year well, not every year, in the second year, we had added another layer of policy implementation. And this was fundamentally a big problem because how can you get ROI if you're getting another layer, if you're adding another layer of code? There's no reuse at all. we detected this problem, and this was why. So part is organizational baggage. So they were sure the policy outcome shouldn't change. That was a requirement, right? The policy outcome shouldn't change. And there was a lot of nervousness around if you change the code, what if the policy outcome is like, what if there's a bug in your refactoring, et cetera, et cetera. There's also our intent. So from the year we started to the second year, we learned so much about the business. We wanted to use a different model. The tech landscape had changed. So for example, we'd written our roles in a clojure DSL. In the second year, there was a clojure forward chaining rules engine already out, so we wanted to use that. One thing that did work in our favor is it just so happened the policy cohort we had implemented in the first year had a lifetime of 4 years. If it had a lifetime of, like, let's say 15 years, then this graph would have lived for 15 years. Because it had a lifetime of 4 years, it would automatically die its sort of natural death in 4 years. And in an organization where you need longevity of 15 years, 4 years is maybe not too bad. So one thing we did is we segregated the policy spec implementation from around the surrounding sort of operational business requirements. Because when we asked why are you fearsome, why are you fearsome, what it actually came out to, the real reason why are you fearing this change of code, the real reason came out to be we're worried that the business process will change because you're changing the policy implementation. And we're like, well, no, that's not really true. We can independently keep the same. We can keep the business process the same because we understand changing business processes is a different sort of effort to your organization. The last thing, I guess, is a big one. In really large enterprise organizations where there is no top management buy-in, it's really difficult to change organizational behavior. It's a sort of slow burn. You show them some evidence about something, they change their views a little bit, but yeah, I don't know what we'll be able to do that. I think we made some segue, but not a lot. The other one I want to talk about is the human problem. So this is one which I thought was not specific to this client, but there were interesting things about this client. So at this client, in the last 5 years, around 10 CXOs changed. Some 20 tech leads, architects changed hands. Lots of developers changed hands, and the tech landscape had changed dramatically. When CXOs change, your leadership vision changes. Somebody wants to build an insurance company for, I don't know, farmers. Somebody wants to build an insurance company for something else. People have different views. When tech leads, architects change, somebody who had originally preferred choreography was now pushing it towards orchestration. And when developers change, somebody wants more mocks, somebody wants less mocks. Humans are the most unique snowflakes. We talk about snowflake machines, virtual environments. All of that is easy. There are algorithms for consensus. Consensus amongst people is the hardest bit. And because it's hard, typically you rely on some model of authority to drive decisions, right? It also creates this sort of authority consensus model, creates some tension between our dream of autonomous teams. We've not been able to figure that out really. Any large program of work needs certain authority structure for it to work. It did cause some unintended evolution paths. So for example, we'd created some libraries for sharing software initially. Let's say we created a common HTTP client so that all services could use the same HTTP client. And the reason that was helpful was the client, let's say, had its own custom authentication protocol. At the start, that seemed pretty cool because we'd reduce the time to start up a service by itself. And when we were beginning, we were doing new services once every week. So it's pretty fast. But somewhere in the middle, one of the new tech leads, new architects, not me, interesting, moved those libraries to sort of more concrete implementations that were hiding underlying, let's say, HTTP clients. So rather than giving a plug-in mechanism to an existing HTTP client like the Apache HTTP client, they just made a concrete interface on top of that, hid the underlying HTTP client. And now, as a result, we're rewriting those libraries because they're actually not accelerating development of services, they're preventing growth of services. When Rebecca's book came out, we read this notion of fitness functions, or I read this notion of fitness functions, and that was really interesting. We actually started to use Arc unit, which was, I think it was an example there, and we were able to implement those sort of fitness functions, but the ones that we were really interested in were really hard to automate. For example, one fitness function that we would have been interested in is every piece of development should make year-on-year policy delivery easier. So no development should make year-on-year policy delivery harder, because the goal is, in a set of, let's say, 3 or 5 years, to reduce the time for new policy implementation. What we started doing, hopefully it works, is just maybe documenting it better. So we picked up every service and we said, what are the key tenets of this service? And what is interesting about this service is this service should be, is this service's job to make it easy for the developer experience? Is this service's job maybe to make it easy to deliver policy? Is this service's job? So we just cataloged it and we sort of published it and it's out there. So hopefully it makes core design architectural changes to those service a bit more forced and deliberate thought. With that, I've got only 5 more minutes. So interestingly, that was my last slide. Thank you. Any questions?